Hi, folks. Welcome to Source Control and Continuous Deployment for a Spreadsheet. I'm Frank Lesniak, and I'm pleased to be with you here today at the Automation and DevOps Summit. Before we jump into things, I want to just quickly introduce myself. I'm a senior architect at West Monroe, and I lead our M365 consulting practice. My passion is really with all things automation and also cybersecurity remediation. That's where I spend a lot of my time. My Twitter handle is up on the slide, and very boringly, it's just my first and last name. If you're watching this live, I'll be in the chat answering questions. If you're watching this not live, at a later date, feel free to reach out to me at any time. I'd be glad to discuss these matters with you. One thing I'll just mention is it's on the slide here. I'm a terrible gardener, but I have a Chicago native plants flower garden. And believe it or not, that is relevant to this talk, as you'll see in a moment. So today, I always like to begin my talks by specifying what the learning objectives are. So I hope you walk away understanding a bit about gardening and landscape architecture. Yes, we're going to cover this today. Yes, it's part of this talk. It'll make more sense when we get into it. I want you to understand what an Excel spreadsheet is made of, and I don't mean the tables and charts and data. I mean the actual Excel file itself. How is it constructed? What is it made of? So you should walk away understanding that. We're going to cover in sort of a survey fashion a bunch of different techniques for getting an Excel spreadsheet under source control. So you should walk away with an appreciation of all of those. And finally, I want you to walk away understanding a technique for constructing an Excel spreadsheet using code. So to achieve these learning objectives, this is our agenda. We're going to get into how I landed on having an important spreadsheet that needs source control. We're going to cover a few different source control techniques today. And then we're going to actually construct an Excel spreadsheet from a combination of CSV and code. So with that, let's get into it. This project all started back in January 2018 when this little peanut, my daughter, learned how to stand up. And when she did, she gravitated toward our solarium, which is pictured here. And really, if you think about the context of it being January in Chicago, this is sort of a bright spot in our household with live plants and having some greenery and bright sun and things to look at as opposed to the brown, gray, dreary outside this time of year. So to get started, I kind of inspected my space and I saw I had a bunch of buckthorn. Buckthorn is very invasive in North America. It's also ecologically kind of a negative plant because it actually harms wildlife in addition to its invasive qualities. So first step was get rid of the buckthorn. And once I did that, you can send an aerial drone up in the sky as I did here, a quadcopter drone, and I was able to take an aerial photo of my property, and I could see that I could see sort of an aerial view of this plot that I was dealing with. And of course, the next thing to do is get that converted to. I used PowerPoint because I was kind of cheating a little bit. You could use Visio, but basically make a plot of your garden and I make an idea of or make a plan for what you want to plant. In other words, the landscape architecture that you're planning. But not knowing much about gardening or plants, or certainly not native plants, which is what I set my mind off that I was gonna do, I didn't really know where to start. And so to get started, I picked up some materials. First, I picked up Bringing Nature Home by Doug Tallamy, and Doug is definitely an expert in native plants and ecology, and he does a really good job, much better than I do, of explaining the importance of using native plants in your landscaping and the tremendous ecological benefits that has. The second book, The Midwestern Native Garden, this is sort of a plant this, not that book for the Midwest United States. Basically, if you look at like some garden plots for butterfly gardens, commonly they'll recommend a butterfly bush. You see that a lot. Well, butterfly bush is actually invasive here in at least in my part of the U.S. I know it's banned in certain states, like it's illegal to plant it anywhere because of how invasive it is. So if you were to look that up in this book, it would say don't plant butterfly bush, instead plant one of these 5, 6, 7, 8, 9, 10 plants. So it's pretty useful from that perspective. Also pictured is the catalog for Prairie Nursery and Prairie Moon Nursery. These are different organizations, and those will become relevant here on the next slide. So if I open up the Prairie Nursery catalog, you'll see some interesting little info cards like this one for Royal Catchfly. And let me zoom that in. This is an actual picture from my garden of my Royal Catchfly. You can see the info card here, and it has important information like the name of the plant, the scientific name or Latin name of the plant, the soil moisture requirements, in this case medium moisture, the type of soil, or loam in this case, the sun requirements, the plant height that you should expect, when the plant blooms, the USDA zone number. In other words, what is the latitude where this plant can grow and thrive, and what is the type of root system that this plant has. The root system, just as a side note, is important if you're planting plants alongside your home or other dwellings on your property, because these root systems can be very deep, and I've heard from actually some structural engineers that native plants can interfere with a house's foundation. So you have to be careful planting these alongside your dwelling, but in this case I was planting them along the fence, and that's all okay. Additionally, you get a nice description of the plant, and you get these benefits icons. So in this case, this one only benefits hummingbirds, which if you look at the shape of the flower here, it's kind of a tube, and the red color tells you, yeah, a hummingbird would totally put its beak in there and lick the nectar out of the flower. That makes a lot of sense. There's other icons as well in the case of Prairie Nursery. So a lot of information here in one little dense card. And we have kind of the same story at Prairie Moon Nursery. They have similar cards. And if I zoom in on the Prairie Smoke one, this one is not my plant. This is a little bit more densely planted than I have my Prairie Smoke. But you get an idea here of the same kinds of properties: the amount of sun that's required, the moisture that's required, the height of the plant, etc. So very useful. Again, we have some benefits or other icons at the top here, and at the bottom you see kind of a key for what you might expect to see in this catalog. So with that, you can kind of see that there's quite a number of variables, actually. We've got the flower color. Obviously, you can see that by looking at the picture of the flower. The time of year that it's expected to flower, the height of the plant, the sun requirements and water requirements, the plant spacing. In other words, if you're making a landscape architecture or a diagram, where should you place the plants? How densely should you put them in your yard? Is this plant typically suitable for home landscaping? The USDA zone number, which we already talked about, in the root type. Benefits, interactions, or features, that's those icons I was pointing out. And finally, soil types. I sort of looked at soil types and I'm like, what the heck does that mean? Going back to the Prairie Nursery catalog, you might have seen sand, loam, and clay. And I know what the word sand means and I know what the word clay means, but surely they don't mean like a beach, a sandy beach, and surely they don't mean a chunk of wet clay that you would use to build a clay pot. So these must mean something else. At least that was my hypothesis. So I did a little more research and I found something called the soil textural triangle, and that's what you see on the left here. Basically, it takes the percentage of clay, percentage of silt, and percentage of sand, and if you know at least two of those things, you can figure out where you are on this diagram. And it turns out you can go dig in your garden plot and kind of empirically determine what your mixture of soil looks like. But for me, it was January or wintertime in Chicago, and the ground is frozen, so I can't readily go dig this up, and I didn't want to wait to place my plant orders. So instead, I turned to the Soil Survey of Cook County, which has a lot of dense information, and it was mildly useful, but really the more useful thing was me going to the UC Davis website and pulling up their Soil Web website. And if I zeroed in on where I live in the United States, I was able to kind of put a pin here on Chicago Avenue, which is where I live. I can see that I'm in zone 2822A. And if I just zoom this in a little bit, you can see that by and large, this area is comprised of anthropomorphic udorthence soil, whatever that means. I am not a soil biologist or ecologist. I don't know anything about this stuff. But if you click on that, you can get a nice breakdown of the soil profile, namely, in this case, the percentage of clay in the soil and the percentage of sand in the soil. And if you look closely, you can see it's about 28% clay and about 8% sand. And so from that, I'm able to look at the diagram on the left, and you can see the bullseye zeroes in on the fact that I must be in a silty, clay, loam type of soil. And that didn't bring me any closer to really understanding what that means. However, you can pick out the word clay and the word loam, and I remember those from the catalog, and so now I know that I have a soil that is comprised of clay and loam. And as it turns out, after kind of learning a little bit more, the more important of those two to pay attention to is clay. The fact that I have clay soil means I need to get plants that tolerate clay. So, so if you're like me, you're probably in information overload, much like a driver would be if they were driving along and saw a street sign like these. And I was certainly feeling like the person at the bottom of this slide as I started to think about all these different variables. So if you're like me, what I did is I cracked open Excel and I started punching all this information into a spreadsheet, and that makes Clippy very happy. So he likes when we use Microsoft Office products. So the spreadsheet looks like this, and basically you're seeing, the type of plant, the name of the plant, the Latin or scientific name of the plant, the common name, where it's native, Cook County, DuPage, etc. These are local counties near me, and it turns out you can look up the native status that specifically on the USDA website. At least you can in Illinois. The height of the plant, the color of the plant's bloom, if the plant blooms at all. Some native plants like grasses or sedges do not bloom, and so those are probably going to just be marked green, or maybe bronze or straw if they happen to, turn to a darker color over winter, and that's worth noting. But generally, this is mostly flower colors. The benefits or interactions or features, like is it deer resistant? Does it attract butterflies? When the plant blooms, and this is important because you might want to select a variety of bloom times for your garden so that you always have something blooming and nice to look at. So of course I wanted to record that. The soil moisture levels, the USDA hardiness zone, which is that northernness, the soil type, the amount of sun that the plant requires, and then the spacing between plants. And there's a few other attributes, but these are most of them. So with all of that, you can think about a hypothetical set of requirements for where I live. And let's say I wanted to plant a plant that's around 2.5 feet tall. I want something native to Cook County because native plants have ecological benefits, like I already mentioned. Arbitrarily, I picked a yellow flower. Yellow flowers are pretty, but you can pick any color. I want something that'll grow in clay soil. Remember, I have sandy clay loam, and of those three words, the word clay is probably the most important thing to pay attention to. I want something that attracts butterflies. And finally, I need something that's deer resistant because if you saw in the aerial view, I live about a block away from the forest preserve, and that means deer wander over onto my property all the time, often setting off my security cameras, my motion lights, and if I'm up late working at that time, it often scares the crap out of me. So my plants need to be deer resistant, meaning that deer do not like to eat them. So if you punch all these parameters in the spreadsheet by using the filter capability in Excel, it turns out there's only two native plants that meet the criteria. The one on the left is black-eyed Susan, also known as brown-eyed Susan, and the one on the right is elm leaf goldenrod. And while these both have their benefits, I think if I'm choosing from a looks perspective, I'm going to choose the black-eyed Susan or brown-eyed Susan on the left. I think it looks better. So you can see the usefulness of this spreadsheet and how in this case it helped me zero right in on a plant that met my requirements or my criteria. And I hope you can see how this would be useful to the community at large, namely that if people kind of set out to plant natives and they have better access to information and can slice and dice the options a little bit better, they're more likely to plant native plants. And this, as I mentioned earlier loosely, this promotes macro ecological benefits. So that's a good thing. I like the idea of being able to share this out with the community. But boy, it'd be nice to be able to take information from the community as well. And a couple of things I was thinking of is, first of all, local observations. Plants may grow differently depending on lighting conditions. Like maybe the plant is supposed to be between 2 and 4 feet tall, but in a partial shade situation where it doesn't have as much light, perhaps its growth is stunted and it only gets to about 1 foot tall. That would be an observation I would want to record as an example. But also other contributions would be nice. I don't know what I'm missing. I'm not an expert in this space, and I could be missing some very beautiful flowering native plants that I'm just not aware of. So I would love to have more contribution to the spreadsheet. So this is a DevOps conference, and you're probably thinking, well, Frank, what's the problem? Just toss this into GitHub and be on your way. And certainly you could do that, but the problem is Excel files are binaries, and any Git repository like GitHub can't really peep into the binary to tell you what exactly changed. It just tells you that something did change. And that's what you see on the screen here. I made a change to the file. The change I made did not change the size of the file, but it changed the content. And I can't tell what was changed other than it just says something was changed. That's not super useful. if you're trying to go through a Git workflow and understand what people are proposing or what changes have been made. So before we go any further, I think it's important to understand what an Excel file is comprised of. And it turns out if you right-click on an Excel file, and because I'm on Windows 11, I have to go to Show More Options. This drives me crazy. But then I get the real menu, and I can go to 7-zip, and I can extract the Excel file into a folder. And you might be thinking, what? Extract an Excel file? Yes, that's right. Turns out XLSX files are actually zip files. And so if you take any Excel file and rename it to .zip, you can then extract it right in Windows. And when you do so, it would look something like this. And you can see that there's that Excel folder. Let's go ahead and click into that, and it would look something like this. And so now you can see I've got a series of XML files. I have a worksheets folder that looks pretty interesting. And I'm going to kind of pause here. But the thing I wanted to point out is that there's a defined structure and there's XML files in here. Before we go any further with this, I want to show you, let's actually make a change and let's kind of see what that change looks like. So I go into my Excel database, and it turns out I had a legitimate typo in here. I had misspelled the word Susan in Brown-Eyed Susan. So let's go ahead and fix that by changing it to S-U-S-A-N. And I'm going to save the file as a new file name because I'm doing a local comparison. So new file name. And when I do that and I open up the two files in WinMerge using the ms-excel file type plugin, this shows me very clearly that it's possible for somebody to determine very specifically what's changed in an Excel file. So this was encouraging. This tells me that this is possible, but it didn't really help me in a Git workflow. So to continue our investigation, I went ahead and took that newly saved Excel file, the one I edited and saved, and I'm going to go ahead and extract that into its own folder. And now if I highlight both folders, I can right-click and I can open those with WinMerge. And this really surprised me. There's a lot of changes here considering I literally changed one character. So I sort of had an oh boy moment, but then I was like, all right, well, let's see what's different here. And I cracked open sheet1.xml because that looked interesting, and I was editing the first sheet in the document, so I thought that's probably the one to check out. So opening that up, the first thing I saw is that the top left cell and the active cell had changed. So meaning I clicked on a different cell before I clicked save, and I moved to a different position of the spreadsheet before I clicked save. And so those changes are being recorded in XML, even though they're not a change to the data set. So this is sort of in some ways, a false flag. It's noise as far as me doing a diff or a review of what's been changed. So this is sort of discouraging. But if I scrolled further down in the file, I found some more interesting changes. And if I look at like cell C176 there in the middle, you can see that the value of that has changed from 857 to 856. And I didn't really know what that meant, but I was kind of guessing that that was an index into some kind of an array. And so I backed out and I went into the shared strings XML file. And it turns out the typoed black-eyed Susan line was deleted from the list of elements here, and the new element was added to the end. And so that explains the change in index, because everything that had an index after the item that was removed would have to be renumbered. And so that's clearly what happened here. And that's why we see so many changes, considering I just changed one character. This must be just by design how Excel works. So the bottom line is, this is not very useful to a human that's trying to come in here and understand what has changed. I just think there's too much room for error in trying to make this determination in any kind of a meaningful way. So yeah, there's plain text changes being shown, but no, they're not understandable to a human, at least not to me. So I thought, let's try something else. Let me crack open PowerShell, and for those that are familiar with PowerShell, you'll probably be aware that there's a module called Import Excel. If you're not a PowerShell person, that's okay. Import Excel is based on the .NET Core module called EP+, and so really we're just wrapping that here. But looking at the PowerShell commands, one really stood out, and that's compare worksheet. That sure sounds like what it is we're trying to do, and so I use that command to compare the two spreadsheets and zero in on the particular worksheet that I'm working on. And in doing that, I was able to find out the row that changed. And so that was encouraging. However, it lists every single cell in the row. And so although I know and I'm looking at Susan and I can see that it changed, if I were to change one of these X's, it would be very cryptic and difficult to determine, especially because I'm going to be scrolling up and down in PowerShell here, I'd be scrolling up and down to figure out what changed, and it's just there's too much room for error. So this really wasn't a good approach either, unfortunately. So that wasn't great. Let's try again. Let's try Spreadsheet Compare. I didn't know about this utility. It's built into Office since Office 2013, and it's still included today. So that sounds encouraging. If I open that up and I compare two different files, it takes me right to the specific cell that's changed. And if I were to expand value 1 and value 2 here, I'd be able to see the data that's changed as well. So that is all very encouraging. But another thing I noticed is that you can see that button at the top called Export Results. And so I clicked that, and I was super encouraged to see that this very succinct output is returned here in Excel. And again, we're in an Office product, so Clippy is extremely happy with us. We're using Microsoft Office and driving up Microsoft's adoption of the product. So I was happy with that, but we're still not integrated with Git in any way. And so I did some Googling, and I landed on the Excel Trail website. They have a blog for how to integrate Spreadsheet Compare with a Git workflow. And let me zoom this for you. This describes the gist of the process. The thing to note here, and I'll just make the long story short for you, Spreadsheet Compare is sort of a weird executable in terms of the parameters or arguments that it's expecting on the command line. You would think, being that we're comparing two different files, that Spreadsheet Compare would be expecting there to be two arguments specified, namely the two files we're trying to compare, the paths of those files. But it doesn't. It needs a text file specified. And in this case, this text file needs to be comprised of two lines, the first line being the first file that you want to compare, and the second line being the path to the second file you want to compare. So you need to have those two lines in the text file, and with that context in mind, if you kind of eyeball this batch file, it probably makes a lot more sense. However, this did not work for me, as it turns out. I had to make some edits. So let's go check out what I edited. First, before I started punching things in, I knew that the path Spreadsheet Compare was wrong. So to get the correct path, I went to the Start menu and opened the location of the shortcut to Spreadsheet Compare. I right-clicked on the shortcut and I opened its properties. And when I did that, I was able to copy what's in this target box to the clipboard. And then I pasted that into a batch file, and you can see it's a much different command that was shown on the blog post previously, and that's because I'm using the click-to-run version of Office, also known as Microsoft 365 Apps for Enterprise, and so that's using App B, and it's sort of a weird, I won't get into the weeds there, but it's sort of a weird command line, and that's why it looks the way it does. I also changed some of the items up here to basically do a find and replace in certain characters before putting those paths into the temp file that's later passed to Spreadsheet Compare. The last thing I did is I had a problem where I was running this, and unfortunately it was throwing an error, basically saying it couldn't find the temp file representing one of the spreadsheets that I was trying to compare. And in looking to the issue further, it turns out that Spreadsheet Compare takes a hot second to start. And because of that, what was happening is git diff would call Spreadsheet Compare, and as Spreadsheet Compare was still loading, git diff would then delete the file, the temp file. Spreadsheet Compare would start, and it would not see the file anywhere and throw an error. So I added this 5-second delay here to effectively snooze the process and wait for Spreadsheet Compare to start sufficiently before deleting that temp file, and that worked just fine. So I saved this batch file as xldiff.bat. And then I had to edit my Git attributes file. This is something, in some ways I'm a Git noob. At least I think of myself that way. I had never edited this file before. So I went in here and following the guide I mentioned previously, I put in a file type filter for any Excel type document. And this is basically saying that whenever you're running a diff against one of these files, I need you to call the Spreadsheet Compare routine, if you will. Next, I went into git bash, and I entered the command git config diff.spreadsheetcompare.command. So when I'm running a diff and somebody calls the spreadsheet compare routine, you need to run the command, and the command is the current working directory and then the xldiff batch file in that current working directory. The current working directory is going to be the root of the repository in this case. So I saved those. I saved this file, the git attributes file, and I ran this command, and I commit the changes to source control. And then I uploaded my Excel file to the repository, and I committed the change. And next I cracked that open, and I made my typo correction from Susan to Susan spelled correctly. Saved the file. This time I used the same file name because I'm using a Git workflow, and saving under the same file name allows me to do that. And if I went back to my git bash prompt, I could type git diff, and when I did that, I got a nice pop-up of Spreadsheet Compare showing me exactly what changed, and I was just so happy with this. But again, this is a little bit of information overload. There's a lot on the screen. To get a little bit more of a succinct view, you can click that Export Results button, which opens Excel and makes Clippy very happy. So we like making Clippy happy, and I'm very happy with the results here. And actually, this worked pretty well for me. But with this being a survey, no survey would be complete without, kind of an exhaustive listing of the other options. And it's definitely worth noting Excel Trail first. This is a commercial product that looks very polished and it looks very drag and drop friendly. It definitely deals with this Git workflow very well. It shows you graphically what changed. It's web-based. I think it's something that a trained business user could use, as opposed to trying to get somebody to do Git diff or something that probably won't be tenable to a non-technical business person. So Excel Trail looked very promising, but on the negative side, it's $420 per user per year. And in my case, with this being a community project, I can't justify that sort of an expense. So for me, this looks solid, but it's sort of out because of the expense associated with it. Another option I actually did kick the tires on is called Zippy. Zippy is a Git filter like you see on the slide that basically when you commit an Excel file and you want to diff that commit, it's going to automatically take that Excel file, the old and the new version. It's going to extract both of those files into a temporary directory and then compare those two directories. And so you get a nice text-based diff when you do that. However, if you think back to the WinMerge example I gave earlier where we opened up two different extracted Excel files after I made a one character change, remember that was very ambiguous to a human like me trying to understand what exactly changed. So it's ambiguous to a human reviewer. It's also ambiguous from a licensing perspective because it has no license stipulated. So if you were to try and use this in a commercial setting, that may be problematic from a licensing perspective. Finally, XLS to text is mentioned frequently on various forums and whatnot pertaining to this subject. It sounded promising, but it's at the end of the day, it's plagued by the same issue that I saw with Zippy and the other related methods. Basically, what this is doing is it's taking that Excel file, it's extracting it, it's taking its constituent parts, all those XML files, and it's combining them in a well-known, well-crafted way into one text file. And the idea is you would store that one text file up in your source control. And so that's a way to have a text-based description or a text-based version of the Excel file. You can use the same utility to convert that text back to an Excel file, but it's plagued by the same issues where if you're trying to diff two different files through git diff or looking at a commit, it's very cryptic. You're not going to be able to tell from a human perspective what exactly was changed. So bringing these options together and summarizing them in a table, I always think that's useful. That's what you're seeing on the screen here. And the first row is not something I've really explicitly talked about, but this is sort of like baseline or status quo. Normally, if you're working with Excel files and you're a Microsoft shop, you probably have those stored in SharePoint, OneDrive, or Teams. Not universally, but likely that's common these days. And what's nice is you can easily view previous versions if you're doing that because these platforms track version history by default. And it's a dead simple workflow. I mean, you're saving and you're getting versioning right from the Excel file itself. Most business users know how to use this just fine without any training. And that's all nice. But on the negative side, we're not really achieving the objectives of being able to see who changed what specifically. I would have to take the two different versions, save them down on my computer, and then run Spreadsheet Compare or something, which would be kind of clunky and painful. It's also pretty difficult without building a workflow in SharePoint or something to gate or review the changes. Not that I want to be heavy-handed, but I want to make sure that somebody's not inserting total garbage into my database. So I do think a sanity check is important there. So that's status quo or baseline, not very useful for my purposes. The next one is doing that whole extraction of the XLSX file into its own folder, and then it's storing the XML contents in a Git repository. And as we've talked about, it's difficult to understand that from a human perspective. So not very tenable as far as being able to review those commits or the diffs, the Git diffs. I didn't really mention this earlier, but it's very space efficient. Git is very good at comparing and storing text files. And so over time, if you had 10,000 commits, this would be a pretty efficient way to store those commits. on the other side of the fence, storing the actual XLSX file in binary format in the Git repository and then using git diff and spreadsheet compare. Obviously, that worked pretty well as far as me looking at what changed. So I really was pleased with that. But on the negative side, with this being a binary file, Git will store every version of that file that was ever committed ever. So if there's 10,000 commits of that file, you have 10,000 copies of the Excel database that's coming across. Or it's first of all, they're being stored in your repository, and then if you were to do a clone of that repository, all of those files or those historical copies of the file would need to be brought down to your computer. You can potentially mitigate that with Git LFS by only bringing down, the most recent version. However, the scope of that is a little bit outside of this talk. So there's a mitigation strategy for that you can consider, but there's kind of an issue there in terms of longevity and scalability. Also, I don't think I mentioned this earlier. Spreadsheet Compare is Windows only, so that's an important consideration if you're on Mac. Also, you need to have Office installed, so perhaps running this from a server that doesn't have Office or a headless build system, that may not be tenable given that those don't typically have Office installed. So there's definitely some limitations there. But again, with this being a community project that I'm not expecting to have a ton of commits to, it's not like the truth about native plants is constantly changing, and I don't expect there to be 20,000 people knocking at my door to edit the spreadsheet. I'm not as worried about the efficiency in storage here or it being a Windows only allowable solution. The final option that I thought was most tenable was the Excel Trail one. Again, looks like a great option. I have no affiliation with this company and I've never used the product, but looking at demos on their website, it looks very solid. It's just that $420 a year per user is way too expensive for a community project such as this one. So that one was out. At this point, you might be wondering or thinking, "Hey, Frank, wait a minute. You promised a demonstration of continuous deployment," and you are correct. I did. So let's talk about an approach that can get that done. My thought is take the Excel database and convert it to CSV, which is obviously human readable, and you can open that CSV file in Excel and make changes, so it's still fairly usable. It's just not that pretty. You're losing all the formatting, you're losing formulas when you do this, but still, it's a good starting point. Then my thought is, when there's a commit or a pull request or something like that, or if we just decide that the Excel sheet is ready for release, quote unquote, then we can use something like GitHub Actions to launch PowerShell. And in PowerShell, we can use the import Excel module to convert the CSV to a proper Excel spreadsheet, apply a bunch of formatting changes, and then ultimately return the compiled spreadsheet as an artifact. That's the general workflow that I think we would incorporate. So what I did to kind of get started in testing this out is I converted the Excel spreadsheet to CSV. And if you're familiar with working with CSV files in PowerShell, you can spot some issues right out of the gate. Namely, that PowerShell is not going to like a sparsely populated first row. It's really expecting that first row to be column headers. So effectively, we need to delete this first row. But furthermore, if we were to delete the first row and just go on our way, we've got some duplicate column headers. You can see the upper left is specifying a 1 foot plant height, and down here it's a 1 foot plant spacing. So, and sorry for metric folks, I'm in the US here, and although I appreciate metric, gotta kind of stick with what the homeland's doing, right? So anyway, so we have to correct these duplicates as well. So to do that, our solution will look something like this. I've deleted the first row and I've appended either height or width to these columns, and so I've basically removed duplicates. I had to do some other cleanup as well, but basically this is what it would look like. And now I can use PowerShell and import CSV and pull that CSV in with no problem. And I can examine the first row of the CSV and it looks pretty good. You can see I've got like key value pairs here representing the columns and the associated values for this first row. So this all looks good. Next, I can take that CSV and use Export Excel to export the CSV to an Excel file and sort of save the first version of that Excel file. I'm using the auto filter parameter, which is basically turning on the drop downs in Excel or the filter at the top. I'm also specifying a worksheet name. And finally, I am using the pass-through parameter, which is basically passing the Excel object back to this Excel variable that I'm storing. Next, I'm cracking open the worksheet and storing that in a variable for ease of use. And I can look at that worksheet and see it's clearly populated with a bunch of data, although this is not very human readable. So next, what I'm ultimately trying to do in this quick demonstration is I want to set the font size down to font size 10 to make it a little bit more readable given the density of the information. So to do that, I need to use the set format commandlet, and that requires me to specify the worksheet and a cell range, and of course the font size. But cell range, let's talk about that for a second. I had to specify a range of cells like A1 to Z26. That would be like you clicking in the upper left cell and dragging your mouse and selecting those cells. So I need to specify the range that I want to apply this font size to, but I need to determine that like dynamically because I don't really know what the range is, right? So it turns out you can do that with the import Excel module, and the way you would do that is you access the dimension property of the worksheet and then the address property of the dimension, and that gives you a string address range, much like I just said, A1 to Z26, or much larger in this case. And then I can run the set format command. Finally, I run close Excel package to close the Excel file so that we're no longer editing it. And it is important to know that this show parameter at the end here will launch Excel and open the file that's in question. So it closes it gracefully and then it launches Excel. That's important to note because if I'm on a build server or a server that doesn't have Excel installed, we would have to omit that parameter, of course. But in this case, I want to launch Excel and it looks something like this. So I'm still absent of formatting and niceties, but I've at least got something that's workable and a good starting point. So there's more work to do here, but it I think demonstrates this for our purposes. The key thing that I think is worth noting is basically I'm shying away from this for my project because well, let me get to this next slide. I think it'll explain it a little bit better. So this is a git diff of the CSV. So I went into the CSV and I made a change on the word Susan, just like we've been doing all along. And that's pretty straightforward because I changed something that's sort of obvious, and you can see it's highlighted well. But if you think about, a scenario where I changed one of these X's, you would see that I changed an X, and that would be obvious, but you wouldn't readily know what column that X belonged to. And so we're still kind of in that situation where this is not all that useful for my purposes. Perhaps if you have a smaller spreadsheet with not so many columns, this would be tenable. But in my case, this doesn't quite work. So I didn't take this any further than I just showed you, but hopefully you get the idea of how you might make this work in the right kind of scenario. So taking this option and putting it into the table format that I showed previously, this is nice because we're working with plain text, and that's very space efficient in a Git workflow. Git stores those changes very efficiently. It's straightforward to crack open the CSV and make edits, although the editing experience is a little less user-friendly because you lose the formatting. So things like word wrap and column widths and things like that are not going to be there. Obviously, you can incorporate this with GitHub Actions or something similar to compile the Excel sheet automatically. And that's all good. But one big negative is we're having to build out some pretty complicated PowerShell code to get this done, at least to get it done to the degree that I want to in my case. And whenever you start building complicated PowerShell code, you have to think about the maintenance of that code. And in particular, if I start thinking about the scenario where maybe I rearrange columns in the CSV or make a change like that, what does that mean in the PowerShell code? Would it be very brittle? Would I have to constantly be making code changes? I don't want to sign myself up for that. So that was a pretty big negative as well. So taking all the options and putting them onto, all the leading options anyway, and putting them onto one succinct spreadsheet, you might be wondering, well, what would you pick, Frank? I can't answer that universally, but I can tell you that for my project, the clear choice is this one, using git diff and spreadsheet compare and storing the actual full Excel file up in the repository. Again, I'm not expecting frequent changes, so I'm not as worried about the scalability of the storage, and I'm not so worried about it being a Windows-only constraint or requiring Office to be installed. Bottom line is this is the easiest thing for me to review changes on. And so this one makes the most sense for my project. So with that, let me wrap up. I'll recap our agenda here and see how we did. I took you through how I ended up with such an important spreadsheet that needs source control, and hopefully you have an appreciation for that. I took you through a number of source control techniques, and you kind of saw my thought process and how I evolved and got to the decision of what to use here. And then finally, I took you through the process of constructing an Excel spreadsheet from a combination of CSV and additional code in PowerShell. So let's review and see if we achieved our learning objectives. Hopefully you have an appreciation for gardening and landscape architecture. That probably surprised you, maybe didn't expect that as part of this talk, but I wanted you to understand a real life scenario where having a spreadsheet under source control actually does make sense. I also wanted to make sure that you understood what an Excel spreadsheet, the actual file, like what it consists of, namely, in this case, a zip file. It's a zip file that contains XML data and other folder structure and whatnot. I wanted you to understand several approaches to getting an Excel spreadsheet under source control. I think we did that. I took you through several, and we talked through pros, cons of each, and I also showed you which one I think is best for my scenario. And then finally, understand a technique for constructing an Excel spreadsheet from code. This is fairly straightforward, but the formatting and changing things to formulas is where things get kind of complicated. It's doable. It's just a lot of work and a lot of code to maintain, in my case anyway. So with that, I want to thank you for joining my session and paying attention. I really hope you, if you're watching this live, I hope you enjoy the rest of Summit. And I am in the chat. If you want to ask a question that you haven't already, please do, or feel free to reach me on Twitter or one of the other locations specified on the slide. Thanks again, and take care.